Still on geometry. In this video, we are looking at angles in a triangle. So we'll start with a typical triangle. We have this triangle, any triangle, and we have the angles inside the triangle. The angles in a triangle, we have angle A, angle B, and angle C. And we say that angle A plus B plus C is equal to 180 degrees, because the sum of angles in a triangle are all equal to 180 degrees. So this is the first theorem we are looking at in triangles. Now let's look at special triangles. Let's start with equilateral triangle. That is that triangle that has all three sides equal to each other. So these small short lines show that the sides are all equal. So we have an equilateral triangle, which is a triangle that has all three sides equal. And if all three sides are equal, therefore all the angles in an equilateral triangle are also equal. And since the sum of angles in a triangle is equal to 180 degrees, and the angles in an equilateral triangle are all equal, therefore those angles are all equal to 60 degrees each. So this is 60 degrees, 60 degrees, 60 degrees. So the angles in an equilateral triangle are all equal to 60 degrees each. Now let's look at another special triangle, the isosceles triangle. The isosceles triangle is the triangle that has two equal sides. Therefore, the third side is not equal to the other two sides. So these small lines show equality of the lines. So these are the equal sides. Now this angle that is opposite this equal side, the angles opposite the equal sides of an isosceles triangle are also equal. And those angles are what we call the base angles. That is, these angles resting on the unequal side. They are called the base angles. So the base angles of an isosceles triangle are equal. Base angles. Now this angle that is the unequal angle, the third angle of an isosceles triangle, the one that is not equal to the base angles, we call it the vertex angle. So it is not equal to the base angles. Okay, having looked at these properties of triangles, now let's look at examples to help us to see how we use these theorems to solve triangles. Now we can see this triangle that we have here. We have angle. This angle is, like, we can see this is two triangles combined inside one triangle. So we're going to solve for all these angles marked A, B, C, and D. So we can see this is angle 31, this is angle 66 given to us, right? So let's solve it alphabetically. Let's start with finding angle A. So for angle A, we are going to start. We see that angle A is on this part of the triangle. So this makes like this part of the triangle. You can see we are given angle 31. We have angle A, we have angle B. So we can't start with solving for interior angles of a triangle. But when we look at this angle A, we see it's sharing a straight line with this 66 degrees angle right here. So we are going to use the theorem of angles on a straight line. We're going to say that angle A plus 66 is equal to 180 degrees. And the reason for making this mathematical statement is that they are angles on a straight line. Angles on a straight line. So that is our reason for making this mathematical statement. Okay, so we are going to say that angle A is equal to, this is 180 on this side, 66 crosses over to be minus 66 degrees. 180 minus 66 is equal to 114 degrees. So angle A is equal to 114 degrees. Now, let's go over to angle B. So we now have that angle A is 114 degrees. So looking at this part of the triangle, we can see that we have the angles 31, 114, and then remaining B. So we know that the sum of angles in a triangle is 180. So we're going to start there. We're going to say that angle B plus, we can write 114 already. But let me just write angle A for clarity. Angle B plus angle A plus 31 is equal to 180 degrees. And our reason for making this statement is that they are sum of angles in a triangle. Yeah, we can use these short forms. Okay, so we have that angle B plus angle A is 114 plus 31. They are all equal to 180 degrees. We're going to collect like terms. We have that angle B is equal to 180 minus 31 plus 114, or we just say minus 31 minus 114, and they are all equal to 35 degrees. So angle B is equal to 35 degrees. Now, since we are solving alphabetically, let's look at angle C. Now, angle C is on this other side of this triangle. So this is the part of the triangle. And we can see this side is equal to this side. Therefore, this is an isosceles triangle. And this is the base. This side is the base of the isosceles triangle. Remember, we said that the base angles of an isosceles triangle, which are the angles that are resting on the base of the isosceles triangle, which is the unequal side of the isosceles triangle. Now, let me slow down. These are the equal sides, right? These short lines show that they are equal. This side is the unequal side. Then these angles resting on the unequal side are the base angles of an isosceles triangle. And we say that the base angles of an isosceles triangle are equal. Now, the angles you are looking for, angle C and angle D, are on the base of this isosceles triangle. Therefore, angle C is equal to angle D. And our reason for saying that is that they are base angles of an isosceles triangle. So this 66 degrees is the vertex angle. Now, we can start by saying that angle C plus D plus 66 are all equal to 180 degrees. And our reason for making this statement is sum of angles in a triangle. We just say angles in a triangle. Okay, so we have that C plus D is equal to 180 minus 66. So we have that 180 minus 66 is equal to 114 degrees. Now, C plus D is equal to 114 degrees. And we are going to say that angle C is equal to angle D, which is equal to 114 over 2. Since both of them are equal to each other, when we divide this into 2, that will give us C and D. So our reason for saying that C is equal to D is base angles of an isos in short, of an isosceles triangle. So we have that angle C, which is equal to angle D, is equal to 57 degrees. So angle C is 57 degrees and angle D is 57 degrees. Now let's consider this other example. We can see this combines all we've learned so far in geometry. It combines parallel lines and a transversal and then angles. So Since we said we are solving alphabetically, let's solve alphabetically. We have E, F, G, H. So we are going to start with angle E. Now, you mustn't solve alphabetically. Let's just get that out of the way. You mustn't solve alphabetically. You can start with anywhere. But sometimes solving alphabetically could help you to look at, like, see where to start from. So we start from angle E. When we look at angle E is on one side of the transversal. These are the parallel lines. The arrows show the parallel lines. So this is on a side of the transversal. So let's look at this. We don't have any corresponding for E, but we have an alternate angle for E. Can you see that? That is Z angle, Z angle. So this is on this transversal. We can see E is on this side and 25 is on this side. So they are alternate angles. So we can say that angle E is equal to 25 degrees. And our reason for this is alternate angles. Alternate angles. Okay, E is out of the way. Beautiful. F, we can see, since we know that E is 25 degrees, we see that F is the angle left inside this triangle. So we can say that F plus E plus 95 are all equal to 180 degrees. So what is our reason for saying this? Beautiful. Angles in a triangle, or sum of angles in a triangle. So we have that angle F plus 25, which is E, plus 95 are all equal to 180 degrees. So we are going to collect like terms right now. We have that angle F plus 5 plus 5, that is 10, we carry 1, that is 120, equal to 180 degrees. Therefore, F is equal to 180 minus 120, which is equal to 60 degrees. So angle F is 60 degrees. So we have found F. Now we go over to G. Now looking at angle G, we can see that angle G is sharing a straight line with this 70 degrees. So we use angles on a straight line, right? Beautiful. So we can see geometry is just easy. Or just solve, 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 and then you'll be able to remember the theorems when you see problems like this. So we have that G plus 70 degrees are all equal to 180 degrees because they are angles on a straight line. Straight line. So we have that G is equal to 180 degrees minus 70 degrees, which is equal to 110 degrees. Beautiful. We are done with G. So we are now left with the last angle we are to look for, which is angle H. Okay, we see that G is already 110, right? 110. So we have, oh, since we have 25, 110, and then H is remaining on this triangle, it's already easy, right? Sum of angles in a triangle. We are going to say that angle H plus G plus 25, H plus angle G plus 25 degrees are all equal to 180 degrees. So, and no, our reason for saying this is angles in a triangle. They are sum of angles in a triangle. So we have that H plus G is 110, 110 plus 25 are all equal to 180. So we collect like terms, right? We have that 180 minus 110 minus 25 are all equal to 45 degrees. Okay, having solved it this way, we found h to be 45 degrees. Now we could as well consider that this h plus e is a complementary angle to 70. Can you see that? Yeah, you could see so many things knowing all the theorems on geometry. We can see that this h plus e are all equal to 70 because they are corresponding angles. We could see that because this is a parallel line, these are parallel lines, and this is a transversal. In this case, this is the transversal we are looking at. So you can as well use that to solve it, to say that h plus e is equal to 70 are in corresponding angles. Therefore, for h, we have to say 70 minus e, which is 25, and we still get 45 degrees. So always look at shapes like this and then be able to remember the theorems, and anyone you see, anyone you could be able to think about, so far it's correct, you're going to get the right answer.